Okay, well, welcome, if you bio students. This is for Mr. Styles' class, and today we're just going to be doing a quick little video on phylogenetic trees, what they are, how to read them, and why they're useful. So the first thing is, what is a phylogenetic tree? And scientists use it as a way to show relationships between different groups of species or organisms. Typically, those are different species. However, if there is a genetic difference between um, one type of E. coli versus another, then that could be shown on a phylogenetic tree. If you look on the left over here on your screen, then you'll see an outline. It's just a brief outline. If you want to take notes on it, I'd recommend using this format. Just kind of lays it out, and then on the right you can see an example of a phylogenetic tree. So the first thing that we want to talk about are the different species seen within a tree, and those are right here. And what we call them in the singular is a taxon, or in plural form it's called a taxa. And depending on where the taxa are found on the tree, then that shows a different degree of relationship to a common ancestor. So each one of these taxa fall on the end of the branch, and those branches or taxa are linked at a node, and that's this region right here. So the key thing about a node is that it represents the most common or most recent common ancestor to those two taxon. So this taxon 1 and taxon 2 are closer in relationship than taxon 3 to 2 or to 1. And that's represented based on this node here. Anything outside of the taxa in question, or the taxa that we're looking at, those are called outgroups. So if we had, so taxon 3 is an outgroup for taxon 1 and 2. If we had another branch going off further from the phylogenetic tree, then that would also be an outgroup. However, into what we are investigating, or the species that we are looking at. The way that we term that, or the word that we use for that term, is called a clade. So a clade are a group of species or organisms that are related through a common ancestor, and it includes that common ancestor. So this area right here is a clade for taxa 1 and taxon 2 with their common ancestor. This area here could be a whole clade because there's a common ancestor for taxon 3, taxon 2, and taxon 1 right here. Taxon 1 could have its own clade if we're just looking at this group right here, so just taxon 1 itself. Or if we're looking at the whole thing, we can go back further in the phylogenetic tree and you look at the whole as a clade. It's sometimes kind of confusing, but it's all just in reference to where you yourself are looking at within the phylogenetic tree. Now, sometimes in different textbooks or different scientists will use different terms for phylogenetic trees, and sometimes you'll hear evolutionary tree, sometimes phylogeny, sometimes cladogram. And for our purposes, all those terms, except for maybe phylogeny, are interchangeable. However, when you get further into science, because I know how much you guys love it, and you're going to investigate this further in your guys' educational career, the more you get into science, then there might be some differentiation in a cladogram being used for more hypothetical purposes, or say we have a new species, how does that relate? And they might build that into a cladogram or classify that in as a cladogram rather than a phylogenetic tree. Also, there are some scientists that will use phylogenetic trees and say that those are more specific because the branches on them represent a degree of relationship. So the smaller the branch, the more closely related they are to that common ancestor. However, that's not universal, so we're going to ignore that for now. Anyway, that's a real quick snapshot of phylogenetic trees. Tomorrow in class we'll go over them again, and we'll probably do a couple worksheets of how to build our own. Anyway, study hard.